Hi, everyone. Thanks for joining us today. And I've got a special guest with us. We've got Nigel Watts with Rheia. It's a special duct air delivery system for your HVAC that can, it's a smaller system. It's easier to work around joist. There's a manifold. Lots of good things about this system that I also do with plumbing. So it just makes sense. Like, why would you do this in plumbing and electrical, but not for duct systems? So Nigel's going to kind of go through this, explain how it works, and the product's called Rheia. So thanks, Nigel, for joining us today.
Yeah, thanks, Matt. Appreciate it. So Rheia is something that's kind of came out of a lot of work. It's not something particularly new to us, maybe to the industry, but for some of us, a couple of my colleagues, we've been working on it for 10 years. It's kind of born out of some research that we did very early on with a company called Ibicus. But fundamentally, it is an HVAC just air distribution system, but it's kind of an engineered solution. It's not something that is kind of put together by the contractor. It is something that's designed and engineered from scratch. The goal is to improve homeowner comfort, reduce the installation time, and meet those ever more stringent energy codes along the way. All of that, with all the benefits that it would bring a contractor and a builder. Primarily, we're focused on residential new construction right now. We see the future moving on into other markets like manufactured housing, off-site manufacturing, remodeling, and so forth. But initially, to get this business up and running, we've been focused on residential home construction, and particularly the larger production home builders. Historically, I won't belabor this too much, but fundamentally, like I said, it came out of an R&D process that was with a company called Ibicus, who are focused on home building innovation and energy efficiency, and have been in that game for about 30 years or so. We developed this idea in that environment, and it kind of came out of just some thoughts and ideas that we had along the way, that looking at the challenges that were coming up with energy codes, with efficiency and productivity in needs in the home building industry. And at a certain point, we got Carrier involved as a kind of a sponsor, as a kind of a joint development partner. They helped fund the effort and get it through this kind of technology validation, commercial feasibility process. And in that process, we also built a pilot home in Pittsburgh, where Ibicus was based, to test it out and to really run it through it, push it through its paces, and make sure that it was really a viable idea that we could then commercialize. At the end of that relationship with Carrier, if you may recall, Carrier was sold off from UTC, and they decided not to continue participation. But we decided we wanted to roll this into a company and make it a real thing, and really turn this into a commercially viable product. And that was when Rheia was born, around about the end of 2019. We persuaded Alan Lang, who's a longtime home building veteran, been with companies like Taylor Morrison, Pulte Homes, Ericsson, and others, and he decided to take it on as an idea, and went through the process of talking to many of the top production home builders, the list of which on the bottom there you see are our investors. Managed to persuade them to invest, and along with 40 other individuals, and Uponor, the plumbing company, they all chipped in as well. And that got us up and running as a company. So Rheia LLC was born at that point. In 2020, we got started with our pilot home program, and just as we got started, the COVID challenge hit. So we struggled for a little while trying to get some pilot homes built, mostly by training the contractors remotely, which is probably a testament to the system, that you could do something new in a home by teaching somebody over a Zoom meeting. It's quite hard to do, but we managed to do that. And then things settled down a bit later in 2020. We got more homes, pilot homes done. We set up our monitoring program at that time. And then at that same time, we kind of wrapped up the software side of the system, and I'll tell you a little bit about that later. And we got our production tooling going for all of our components. That's quite an effort and quite an expense to do that. But along that process, we also had to do some UL certifications, which is a fairly timely process too. But we got through 2020 well. 2021 started to pick up, so that's when we started to turn the pilot homes into some production homes. And we went through another round of capital just to support us on through last year. And around about summer last year, things really started to take off, and that's when we're really starting to put our system in homes. We did about, I think, 1,000 homes last year, 800, something like that. And this year we're shooting for upwards on the high end of 20,000. So we may be somewhere between 10 and 20 by the end of this year. So in terms of the company, there's about 20 people in the company now. A lot of them are out in the field. We have a couple of field people in most big markets that we're focused on right now. So we've got a couple of people in the Midwest. We've got someone up in the Northwest, here in the Southwest, in Phoenix, and Southeast. That's covering us for the time being, but that's just going to grow into other markets. Texas will be another market. Denver area will be another one, so forth as we grow. And then we have a small team here of about 10 people looking at, from my side of things, the product development side, support, the software development aspect of it, and supply chain. So why do we need it? Just to kind of reiterate what I briefly mentioned at the beginning there. Really what we need in the industry is a system for HVAC that's similar, as you said, Matt, to electrical and plumbing. It's got to have the same kind of technology, the same kind of thinking around it as a system, rather than something that's put together, almost ad hoc in the field. And that's what we've developed. We did it in a way that makes it cost effective, and that's really hard to do in the production home building industry to compete with the conventional systems. But we're very cost effective, primarily because we have a faster labor component to the system. So we can balance off our component costs and duct costs with the labor aspect of it. And so we're very cost competitive from that perspective. And we're also focused on moving the ducts and equipment into the conditioned space. So that's a kind of a prerequisite for our system. We think and we believe that it makes no sense to put an HVAC system with ductwork in an attic. If you think about the temperatures in an attic in the summer and winter and extreme climates, it's crazy to do that. It doesn't really make sense from an energy efficiency perspective. And as probably most of the audience knows, a lot of the energy in a home, maybe up to 50% of it is used in the heating and cooling of the home. And the efficiency of that system is not particularly high when it's all running in an attic. So that's why we advocate for putting all of our system in conditioned space. So fundamentally, what are the features of our system? We like to think of it as PEX plumbing for HVAC. So it's kind of a similar manifold and home run type approach. We use a small diameter duct that fits in 2x4 walls. So it's a 3-inch duct. We do have a 4-inch duct in certain circumstances where we need to push more air, but primarily it's 3 inches. And we use a home run layout for that system with a central manifold right next to the air handler that then runs ducts to each room from that central point. And we work with any conventional air handler. A common question we get is when they see the system is, oh, it's high velocity. We're not high velocity by that measure. We are operating at standard conventional air handler static pressures for supply and return. And basically it works because we just run enough ducts to each room to relieve those pressures and to feed the amount of air that's needed in each room. So it's not a very complex concept in that sense. There's some kind of secret sauce behind figuring out how to get those airflows assessed and measured, but I'll talk about that in a little bit. Everything connects together as far as all of our connector components, elbows and manifold takeoffs and boots and registers. Everything is a snap fit system. So we don't have any tape or mastic in any of our components, in any of the setup. That saves a massive amount of time. And it's also a better performing solution from an air tightness perspective. We describe ourselves as near airtight. I wouldn't say absolutely airtight because that's not true, but the amount of leakage we get is very small. And we can very easily meet Energy Star requirements for duct leakage in a house. Our ducts being in conditioned space, strictly speaking by the code, you don't really need to test the duct system, but we don't mind if they do that anyway. It's a good thing to do. It's always good to make sure you have a well-performing system before you close the house up. And the other key thing that we have that helps with our system is we have adjustable dampers in every duct. And we put those at the end of the duct run at the boot. We can do that because of the low leakage. We don't have much in the way of air loss along that duct other than what we know is what's predictable from each duct run. And being able to put those dampers there makes them easy to adjust. And we use those dampers in our balancing process. I'll tell you a little bit about that in a moment as well. The duct connections, here's what some of the components look like. We have some UL requirements that we kind of voluntarily comply with. We actually had UL create a new UL standard for us for this connection system. It's called UL 181C. It's not in the building codes, but we decided to raise the bar and say, hey, these systems can do better. And it's a whole set of requirements that involve heat soak tests at high temperatures, leakage tests, crush tests, torque tests, all sorts of, I think it's 17 of them in all. Mold growth test is another one. So we pass all of that, and we kind of have established that standard as what we think all connection systems should comply with. And as you can see from the system, it's fairly basic. The key component that we have is a patented threaded ferrule. That we call it a ferrule. It basically will air seal to our duct, which has a slight stretch in the fabric that's used in this duct. And when you thread those two together, you end up with a pretty much an airtight seal, a near airtight seal. And it's very quick to do. So a couple of twists and it's connected. There's no mastic, no tape required after the fact to seal that off. Then each component will snap to each other through a kind of a simple friction fit and a snap fit. And it's simply a quick push and a click, and you hear the click and the system's connected together, and we get a near airtight seal out of that connection. The rest of the components are pretty straightforward. We have a couple of other pieces aside from the ferrule that make up our connections. We have a 45-degree elbow. We use those in tight corners and tight spaces where we don't want to have the duct to be crushed or kinked or bent too much to maintain good airflow. A couple of those elbows snap fitted together make a 90-degree bend. That's useful when you're going up a wall and then directly 90 degrees out into a floor space, for example. It stops that corner from being too tight and too compressed. And it kind of keeps it within that typical code requirement of sweep of a curve of a duct. And those pieces are all compliant with the UL 181C. We also decided to have them comply with UL 2043, which is a heat and smoke release test. Just to be sure, just to be safe, again, it's not absolutely required by code, but code officials want to see something that performs well when it's a new system. That we get that question quite a bit. They're looking for things to be able to measure to, because the codes themselves are not very specific. So we decided to do that as well. The rest of the components are basically our boots and our manifold takeoff. These boots work in different situations. We have a high sidewall boot for a duct that runs up a wall, and we position those boots fairly high on the wall. There's a good reason for that, which I'll tell you about in a moment. We have a pass-through boot, which kind of works within a soffit or any kind of a direct run where the duct comes directly from behind. And then we have a ceiling boot, which kind of looks quite a bit like a typical recessed can assembly. With those comes some hanger bars. We can screw those either directly to wood, or we can use the hanger bars and space them between joists or in stud bays. And then we have an inner and outer manifold takeoff that works with our manifold. And the manifold itself is a site built or a shop built 1 inch or 1.5 inch ductboard box assembly. That box assembly is built to typical NYMA specifications, where you're building it. It's like building a splitter box, if you like, that you typically build in an attic today. So it's built to a certain size and specifications that we provide. There's a 3-inch hole that's drilled in a certain pattern in the manifold, and from there our ductboard takeoff components snap fit to that part, creating a seal. And that takeoff is then used with the ferrule in the duct to snap the ducts to it. So fairly straightforward, fairly simple to do. Contractors are familiar with that material. And we're also looking at a sheet metal solution as well in certain markets. Certain areas like the Northwest, they're not a big fan of ductboard for traditional, historical reasons, but overall they are, they like sheet metal. So we have a sheet metal takeoff approach as well that we can use. The diffusers themselves, there's two different types. There's what we call a slotted diffuser, which works with our sidewall boots. And just a little discussion here about how those work. The reason we put these high on a wall is because we get good airflow into a room and good reach into a room by positioning them high on the wall. Another benefit of that is that you don't have to worry about furniture covering up your floor registers if you have floor registers, for example. So that's a benefit that really can significantly impact comfort in a room, especially in bedrooms where there may be no option to put the bed other than over the floor diffuser or a chair that goes over it, or there's drapes by a window that cover it. So we put these high on the wall out of the way, and in that, by doing so, gives us a good opportunity to throw air a good distance into a room. Similarly, with the ceiling diffuser, these are designed again to distribute air into a room very efficiently. Everything is fairly aerodynamically designed, so we don't have a lot of losses there in terms of getting the air out of the boot through the register diffuser and into the room. And what they look like when they're installed is shown in some of these photographs here. So you'll see there's several in a room, and the one on the left here, there's 4 on the ceiling. And the reason for doing that is because obviously we have a smaller diameter duct, so we need more ducts per room. And running more ducts per room gives you a different advantage. It allows you to distribute that air more efficiently into the room. So you're distributing it from more points into a room. You get better air mixing because of that. And as a result, the room will feel more comfortable. So there's less chance of hot and cold spots in a room because of that. And again, because they're out of the way, there's no risk of anything being blocked or obstructed. On the high sidewalls, there's a couple of images there on the right. You can see some examples of that. And there's lots of different options here in terms of how to lay them out in a room. But fundamentally, you're looking to throw that air into the room as effectively as possible by spacing out those diffusers across a wall, up on a bulkhead, or wherever it may be. So fundamentally, from the way we kind of talk to a home builder about the value, there's a cost-effective aspect of this, of moving the ducts into conditioned space. The builder does have to take some things into account, depending on where they are in the country, as to whether they have their air handlers already in the conditioned space. Places like Florida and in the Mid-Atlantic, Northeast, Northwest, that's already the case. Southeast, Southwest, that's a different exercise. So the builder has to go through some process to think about how to do that. But that's something that we work on directly with the home builders and their architecture teams. There is a PERS points gain by getting ducts out of attics into conditioned space. So that's a benefit. There's then also, because of that, a reduced cooling tonnage in the house. So that's a cost savings for the builder and an efficiency saving as well. And in many cases, there's a federal or state tax credit to doing this type of change and moving ducts out of attics and into conditioned space. You can get you can take advantage of the 45L federal tax credit, which is a $2,000 per home credit. That's something that's very interesting to the home builder, obviously. There's an improvement in cycle time. We see anything between 25 and 50% savings in the amount of time it takes to do an installation. It's things like a typical 2,000 square foot townhome. We can cut that in half, that labor time in half easily. So it gives the contractors the opportunity to do more work with the same crews. As you know, there's a labor shortage. So from that perspective, if they can do more houses quicker, they're all for it. And obviously from the builder's perspective, more homes per crew is obviously beneficial from their side as well. And we get from that perspective, in the short time that we've been in production, had people living in homes, we're seeing some good feedback on the comfort side. There's a lot of aspects to comfort. Obviously, it's not just the HVAC. humidity and how people feel about comfort and all the other things that affect it, airflow and all of that. But this adds to that feeling of a more comfortable environment. And as a result, so far, we're seeing fewer callbacks from those situations. The last one is job site waste. That's something that obviously costs the builder money. Filling up containers of waste is obviously expensive to haul away. Our system typically is very material efficient from that perspective. You'll not see lots of feet of duct thrown into the trailer. You'll not see anything else wasted. We don't have the components themselves. If there's some that are left over for whatever reason after the fact, they're going to take them to the next job. They're not going to throw them away. So I talked a little bit about the software process, and this is an interesting piece to the system. It's kind of like the other side of the equation. And if you think about how it's done today, the traditional process, manual J, manual S to do a duct design, then obviously manual D to lay it out and size the duct system. That's all basically code mandated today. And then there's the optional part of the process, which is manual T. And then there's an airflow balancing process that should occur once the system's installed, and reporting out of that information. And what we see in production home building in particular is, the manual T process is not really done. Sometimes it's practiced, usually not. And then airflow balancing is kind of it's a bit of a guesswork process. To adjust a trunk and branch system effectively to get it all balanced is really quite hard and time consuming. So generally speaking, it's not done. The contractor will tend to wait until there's a callback, go back and make some adjustments and hope that those will work. So we looked at that process and we said, there's a better way to do it. And our method is kind of a more circular approach. We do manual J and manual S as is done today. That's required by code anyway. And that's what we need in order to do our design. So our kind of version of manual D, or Rheia D, if you like, is to design to a more accurate airflow prediction. So because we know what the losses are along our ducts on a duct run, based on the roughness factor of the duct when it's installed, based on the components and what their losses are, what an elbow loss is, going around a 90-degree turn, and what the boot losses are and the diffusers, we can actually make some pretty decent predictions on what the airflow is going to be at the end of each duct. And that helps us figure out exactly what to expect when the system's installed. So we then take that model, that data model, and we use that in our Rheia Verify app. And that app is a simple way of balancing the house by the technician that involves the following process. Basically, all they do, they'll take their flow hood, they'll set the system to get the system running. They will take a measurement at each diffuser in the house. That's entered into the app, and once they've gone through the house once, the app will then compare that airflow measured airflow at the end of the duct run in the room to what was predicted by the design, and it will then tell the technician to adjust the damper that's at the end of each duct in the boot to the correct number that would meet the airflow that was predicted to a balanced degree. So there's a bit of give and take there, but the software works out specifically how much air you need for each duct and what the damper setting should be. So once they set those dampers, that system is then balanced, and it'll be quite close to the ACA requirements at that point. In terms of the ACA has I think ACA Standard 5 says 20% or 25 CFM performance within the design, and we can pretty much meet that almost every time. We get some situations where there may be quite a lot of leakage into a house, and that would affect the comfort as well, but some things we don't have control over. But this process gets us a nice, fairly accurate balance of the home. And from there, we can create a report. So we can give that report to the contractor, we give that report to the builder. We can say, hey, this is how this house was balanced. If there's an issue later on with the homeowner, if something changes or the homeowner decides to pull those diffusers off and poke around inside a boot and do something and put the system out of balance, the contractor can come back in very easily, look at the app and check again how each damper is set and reset if necessary. So it's a great way to model up and to predict and then check to make sure that we're meeting those manual J requirements. So in terms of just a little bit on where we are right now, you can see blue is where we are in production. As I mentioned before, we're focused on the residential home builders at the moment, the production side of things, and that will change over time as we get more into distribution and the product becomes more available. But we're focused heavily, and actually California is going to be coming online this year, Texas, and Nevada, and New Mexico, and you can see there on the East Coast as well, where we're about to be in fact, in Michigan right now, we are in production. So we just got the code changed there. We just got some code approvals for that state that was required. And then in terms of growth, 2021 was our kind of pilot startup year. Now we're heavily into production. We're shooting for as many as 20,000 homes this year, and that's our target for the end of the year. But pretty rapid growth. The thing that's probably slowing us down is, like with everyone else, is supply chain stuff. So we were quite shrewd and quite lucky in a way in what we did early on with Rheia. Our manufacturing for the most part is in the US. So we didn't have too many headaches from any supply from China. We had a couple of things coming in there. The hanger bar, for example, comes in from China at the moment, but we're looking at some other sources here in the US or in North America as well for that. And we're looking at, we're actually setting up a new plant for the plastics component manufacturing down in Louisville this year. We'll probably have another one of those maybe in Nevada next year. And then we're building on our distribution chain as well, so the supply chain side. In some cases, we're delivering direct to contractors, depends on their size and what they're capable of receiving. Some cases we're going through distribution, and that kind of helps fulfill those markets. So we're strategically locating our distributor relationships within the markets that we're focused on. Just so in terms of kind of the typical questions we get, and this, when people see our system, they generally ask these 4 questions: static pressure. What is the static pressure? You guys are going to have high static pressure because you have small ducts. We in fact don't, because of the fact that we have ducts that we have a system where we determine how many ducts will be needed per room in order to feed the right amount of CFM into that room, and so basically that process then adds ducts to the system to make and monitors what the typical static pressure is of the system, supply and return side. So that's the simple method of controlling the static pressure, is just to make sure you have enough ducts. On the return side, we advocate for central return. Doesn't have to be a central return, but we see central returns, they perform easily as well as dedicated returns. Dedicated returns are challenging unless you really pay attention to them and do them really well. So in a more custom environment, it's probably okay. But in general, for production home builders, they tend to lean towards the central return solution because it's simpler and easier. And we use jump ducts and pass-through ducts in order to, relieve pressures in rooms to make sure that we have a good return static pressure as well. So we monitor that in the design process. As far as meeting the room CFMs, that's another question. Again, they see small ducts and they think that, there's not enough air going into a room. But again, if we have 3 or 4 ducts in a room and diffusers in a room versus one larger one, then you get the same amount of airflow and you get better mixing of that air because you're pushing that air into the room in different points. Cold spots, or hot spots tend to happen because you might have a register in the floor, for example, that's located a bit too close to the door or not too near a return, and the system will short circuit in that area. But with us, because you're spreading those ducts out throughout the room more effectively, you're getting better airflow into a room and better mixing. And then the balancing process, we described the balancing process, and kind of we always challenge the contractor about how they balance today, and often it's not a very sophisticated method that they use. They fire up the system and kind of check a little bit to make sure each chair is getting some rooms, and then that's their balancing process. When ours is much more sophisticated and more accurate. I mentioned the pilot homes that we did in 2021. We've done several homes where we did a monitoring program as well, where we put sensors in, monitored them over a period of time. We did about 12 townhomes and 6 single-family homes. We did a few side-by-sides as well, comparing conventional to our system, primarily looking at the temperature deltas within the house. So, how does our system perform compared to conventional, and what are those temperature deltas? Different types of houses have different situations. In the Midwest or up in the colder markets, a slab on grade 2-story house, you'll often see a temperature stratification problem because those slabs are very cold, often not required to be insulated. So it creates a lot of stack effect in the house. So we try and design for that and to alleviate that. Townhomes as well, they can typically have quite a significant stack effect between a room that might be on the basement floor up to the 3rd floor bedroom, and there's issues there. So again, with our system, we can somewhat control that better. But overall, we've been monitoring and looking and checking and making some tweaks. We actually designed a new diffuser for the northern market that blows air a bit more directionally down rather than out across the ceiling, and that works better than our original diffuser we were using in that market. So we're monitoring these, watching and making changes to our algorithms and to our product in order to try and further improve the performance of the system. And then the last slide just kind of sums that up a little bit with some examples of some average numbers that we've seen. So we can quite readily keep within those ACA limits that they define as a temperature delta, room to room, floor to floor, 4 degrees in heating and 6 degrees in cooling. And in our monitoring, we see that we can meet that number and exceed it in many cases. And there's a couple of cases we've seen sub 2 degree temperature deltas on a townhome, for example, in Pittsburgh. So if the house is reasonably well sealed and the system is installed well, we have great success with that. So pretty confident in the way the system is performing, and again, watching carefully for homeowner complaints, which we haven't seen any yet, but the system's performing really well. And that summarizes where we are. And it's an exciting year this year. It's very busy, as you can imagine. Trying to grow from a couple of 1,000 homes to 20,000 is a challenge, but I think we're in pretty good shape. We've got a supply chain for our system that's pretty well rounded. We're managing how fast we grow at the moment based on our production. But as we get into the next quarter, our production capacity is going to go up significantly anyway. So we don't have too many concerns there.
Yeah, thanks for going through that. Very good presentation. So some of the questions that I had, and just looking at that, one, I just wanted, from a value proposition, as a renovation contractor and also a custom home builder, the fact that your ducts are small, if we have tray ceilings or challenging pathways to get to certain locations, the fact that you have smaller ductwork is a benefit to us, because especially if you're in a basement doing a retrofit, obviously with a new home, you can have either I-joist or open up trusses where things can go through. But if you don't have that benefit, that luxury, I think your product is well suited to be able to handle that. Also, just like a lot of our clients are very particular about, like if you look at a standard return or supply grill, they're not the most attractive, and typically default is like whatever you can find on the shelf, stamped, coated, and then it just looks very cheap, doesn't really fit snug to the wall. Yours seems to have a lot more of a modern look, so it just looks like another piece of equipment on the wall and blends in with the lights, and people, when they look at it, they probably don't even know what it is. So those are some of the benefits that I see for our clients for sure. I do have a question for you. So you mentioned return air pathways and also just having those central returns. If we choose to balance each room out, the system could still do that. We could still have supplies and returns in each zone, correct?
Yes, yeah, that's not an issue. It's all about design, right? If you design the system correctly with dedicated returns, and you're managing the static pressure back to the air handler, it's not a problem. It's all about design, right? And we've kind of defaulted to the central return for production home building because
Yeah.
generally speaking, they don't put the time in to do that type of level of design that you would for a custom home or for a major remodel.
Yeah, I like the fact that you guys require everything to be with the conditioned space. Makes sense. One of our big things and values that we sell to our clients, and that's why I was asking about those balanced rooms, would be air filtration. So,
Yeah.
based on the fact that you'd have multiple supplies, multiple returns in each area, it means that you're getting a larger and more diverse sample of air instead of just from one area. And I would imagine, and I would love to look at the testing on this to see, how many more particulates you can pull out of the air just based on the fact that your system has more of a coverage of the space. So that would be interesting to see as well, especially as people occupy it.
That's a great point. We haven't really looked at that too much. Obviously indoor air quality is a big topic these days, and it's which is good. I think COVID has helped push that along as well. And we're all in favor of better air filtration systems and ERV approach to fresh air. Any of that is obviously good. From our perspective, it doesn't impact our system. At some point we may look at look at the return side and maybe componentize that as well in a similar way and try and improve the aesthetics and performance there. One issue with central returns, a typical complaint is the noise, which is a fair argument because of those fairly large return grills are pulling a lot of air through one location. And metal grills, metal edges, they do tend to, those blades will vibrate and they do make a bit of noise. So we're going to look at that, but there are ways to design around that too as well, as long as you're not pulling the air directly straight into the air handler. If you do have a flex duct return that's got a little bit of a pathway to it, that'll help reduce that noise significantly.
But it sounds like you can use the same grills on the supplies and the returns if you wanted to balance it out, CFM for CFM with your system.
Yeah. And again, we are just focused on the distribution side at the moment. We had to, pick our kind of first solution to the market.
Got it.
And we did design those grills to be kind of just neutral and not, something that just disappears, right? We don't want to, it's not like we want to make it obvious in a room what it is. You and I, when we look at one of these systems, we look at those, but I think your average homeowner, they don't spend much time looking up at the ceiling.
Absolutely. You mentioned ERVs, and that was an interesting point. So a lot of they used to have spot ERVs. Now a lot of the companies are coming in with like a 100 CFM, 200 CFM plus system. Some of these ERVs don't necessarily have the distribution system. They have like, hey, use these kind of ductwork. So I'm assuming that your product could work with an ERV if it was designed, with that manufacturer. Obviously it'd be a custom design, but it looks like this could help balance out fresh air if somebody wanted to have a separate ERV system outside of their normal air distribution system.
Yeah, absolutely. Either one. We have been doing houses with one builder who's mandating an ERV in every house, so as part of their future program. So if it's feeding into the air supply, feeding into the air handler, obviously it's going to go into the return side, not a problem, and a separate system as well. We don't see an issue. It doesn't really impact how our system works.
Got it. Yeah, I was actually just thinking from a retrofit point of view, because I've got a lot of clients that are in houses. I met with a client yesterday, felt horrible. They have some lung issues.
Right.
Again, everything we did in the house was healthy. It was just a renovation. Over the years, I've told them, as you replace equipment, go with this type of equipment, get the natural gas, open combustion out, go with better filtration. But then I was like, you know what, we really need to get an ERV in this house just because to get the fresh air. So from a retrofit point of view, looking at an ERV and be able to run that, not necessarily, independent of the system, sometimes needs to be an option for clients. So it's good to know that your product potentially work with that. So as far as distribution, it sounds like most HVAC installers would purchase this directly. It's not something it's B2B, it's not B2C. They would provided as part of their installation. So a consumer doesn't need to go out there and buy this, correct?
No, correct. No, we're not doing any B2C at the moment. We're, as still starting up as a company, in the growing phase. We got to focus on our market. You're right. Quite a few of the contractors, especially the bigger contractors who might be, be in a couple of markets in particular, they kind of act as distributors themselves anyway. They buy so much material. They have warehousing to accommodate for that. Another reason they like our system is it's pretty compact, right? So you could fit an entire system on a 4x4 pallet for a house. Which on a conventional system, you kind of probably need 2 or 3 pallets to do that. So they don't mind taking us in from an inventory perspective because it's fairly compact. And the duct, you can get about 300 feet of duct in a box, a 20 by 20 by 20 box, and so 3 boxes for duct, and then a couple of boxes for the components, 3 or 4 boxes for components, and the rest of it can be returned, right? You can squeeze all that on a pallet pretty readily.
Well, I'm a custom builder. We do custom renovations, but the fact that you guys targeted more the speculative market first, I picked up on this. I'm not sure a lot of people picked up on this. Means that I love my spec builders, but if something changes 50 cents, they're crying about it. It's like you can't change that code, which means that your product must be cost comparative to traditional systems. You mentioned this the first time we spoke on the phone about this, and that was very impressive that you guys were able to do the trade-off with labor and materials.
Yeah, it was the hardest part of the whole process, is to figure out, could we really do this cost effectively, right? Because we knew, as you correctly mentioned, home builders, their margins are very tight, and so they're very proactive in the procurement side of the equation. Basically, we just look at it as kind of a balanced scale. We have, you can see my hands here, conventional systems, labor is fairly high, and all of the components are fairly basic and cheap, right? It's kind of like, that's the way they do it. It's a lot of labor, and try and get the sheet metal and the flex duct for as little as possible. We just shifted that equation. We said, well, what if we have a system where our components are a bit more expensive, but it's not 50%, for example. It might be, and it depends on the market. In some markets, we're actually lower cost on the material as well. But the gain on the labor side is significant. It helps the contractor and it helps the builder. From the contractor's perspective, they will basically procure the materials, and they'll provide a quote to the builder for the job. This is what this job costs. And whether the builder doesn't really care if it's all labor or all materials or some balance of the two. It doesn't matter to them, right? But we want the contractor to win, because obviously they're the ones who are doing the installations. So giving them this labor benefit and still being able to mark up the material and the product is what they're looking for, and that helps just ease that pain on the labor side of not having enough crews to do the work that's out there. Builders there's more work out there than there are people to install HVAC systems right now. So if we can get that contractor more work with the same crews, they're going to win as well, right?
Well, that's going to be my next question. Obviously, there's a labor shortage everywhere. For people entering into the market, it seems like you don't have to know as much. There's only, I think I saw 16 SKUs for a typical system. That's right. You could have hundreds of SKUs to do an installation. There's some customization you have to do. I mean, the only customization you have would be the plenum, which, there's different ways of doing that. As far as training, do you guys have videos? Do you how do you get new HVAC contractors up and going quickly so the transition is seamless? Yeah,
that's a great point. So we have a fairly straightforward training program. Actually, I'm working, one of my projects right now is to put all this into a more formal manner, but we use our field guys to build a relationship with the code officials, with the builder, and with the contractor as a group. So we keep all three of them informed and along the way as we get into a pilot home. And we use the pilot home process to kind of train the contractor, and then we can bring other contractors in, other builders in to see this pilot home. And we do the training on site. Basically, we have videos, we have handout materials as well, but you can't beat, one-on-one, standing in front of them. And it's about a half-hour process, because all you're teaching them is, look at the drawing, figure out where the boots are going to go, figure out, once you figure out what the location is, you fasten the boots to the wall. And then the rest of it is all you can show them by hand. And all they're doing is clicking and snap fitting parts together. We're not asking them to then go back and add mastic and make sure the mastic is properly applied, and all those things that can go wrong with that part of the process. And although there's a lot more ducts per house, there's between 750, 800, 900, depends on the house design, but there's quite a few 100 feet of duct. It's a very durable duct. It's not insulated, so it's easy to handle. And you can feed it through walls and floors and trusses and very, very quickly. And you just drag and pull. It slides through everything. It's a very good duct from that perspective. There's nothing to get snagged. You're not climbing up into the attic, balancing on the floor trusses, floor joists, trying to put something together. Everything's done really quickly. Contractors love it as well because it's not messy. Mastic is the messy process.
Yep.
And with sheet metal, slicing up your fingers is pretty common.
Yep.
We've probably all done that a few times. And you don't have to worry about that either. So there's some benefits there as well. So the actual installer person in the field, who once they've felt it and done it and put an install in, they love it from that perspective. They just love working with it because it's easy.
Well, I don't know if you intended to. Obviously, you've got a better system. I'm sold on it. I look forward to using this on our projects. But I was also just thinking about the piece that you guys are bringing to a job site. First of all, HVAC contractors love to hack through our framing. So this is like, there's less hacking there.
Right.
There's less fights between the plumbers, the electricians, and the HVAC contractors now about, like, you have a big duct going through the space. Well, no one else can go through that space. So really real estate inside the walls is at a premium. And it looks like your system allows for more people to be able to play together on the same playground without fighting. Yeah,
it's a good point. It does provide another kind of benefit. And if there is some situation where, the from an HVAC perspective, you got to run that duct in a little bit of a different direction from the design, it doesn't really matter, right? Because even if that duct is 5 feet longer, when we do the verify process and we measure the airflow, if it's a bit under what the design said it should be, we have that damper blade, we can open it up a little bit more and rebalance based on the actual installation. If there's some changes had to be, because inevitably, there's always something different about the house than was expected. That happens quite a lot. And then again, if typically the drain and waste vent stuff is already installed ahead of HVAC. That happens quite a lot. And then the rest of the plumbing's done afterwards. But now with, that's rigid ductwork, rigid pipe work from the plumbing perspective. But smaller ducts can more easily route around things and go around those situations and avoid those kind of conflicts.
And you mentioned pilot products or projects. I saw that you guys working in Georgia already. I know some of the HVAC contractors that are working with this, and they said they love it. We're also using this and this is how we met, on the 1920s makeover ATL, which is a passive house. So when you're talking about that degree difference between rooms, I can't wait to test this, because we're gonna have so much insulation that it's going to be fairly consistent. And also I've got some other projects coming up that I want to get my designers involved in, because we were trying to figure out, how do we heat and cool this one vaulted area, and how do we put the ductwork in such a way that we're not doing drop down chases and whatnot. And I think this is actually the solution. And this was from a problem that I saw a couple of days ago. So we look forward to working with you on multiple projects, because I think this is the solution that I know you're on the production side, but as this migrates to the custom side, I think custom builders are going to love this.
Yeah. Well, that's, again, our goal is to get it in as many houses as possible. We think this strategy makes sense. As we get a contractor up and running with 1 or 2 bigger production home builders, then they're going to say what you just said. They're going to say, okay, hey, I can apply this to this regional builder, this smaller project. It works on these projects too. And we're going to let them kind of disseminate that through the rest of the market without us having to chase, every small builder out there, because obviously there's a lot, and
Absolutely.
from a company perspective, that's a lot of manpower.
And we'll be digitally we're gonna do video of all the stuff that we're installing. So again, so we can train all of our crews on how to do it.
Yeah.
And it's also, we're going to insert those videos into the virtual tour they have, so people can kind of walk around, see everything before the drywall. So we've already filmed the house as it is, which was a horrible house. We're going to film it right before we install the drywall, because all these showcase houses, they show you like, hey, look at these beautiful countertops. It's like, as a builder, as a high performance builder, like what's behind the wall. So we're going to show us behind the walls, behind the drywall, and then the final reveal, so you can see it all in phases, how it goes together. I'm really excited about this. I truly believe that this is going to be how everyone's going to be doing ductwork in 10 years. So the fact that you guys took the time to, and why hasn't this happened yet? I don't understand. This is such a good idea. It's 2022. I can't believe you guys are the first ones to have thought of this, but that's amazing that nobody else has.
Yeah, I don't know. It's, obviously there's the high velocity systems out there which have a place, and that they're good systems as well. I don't know. It's something that we stumbled upon ourselves, and when the folks were working at Ibicus, it just as an idea that popped into one of the guys' heads. It was just hey, hang on a second. Why are we putting all this ductwork in the attic? We know there's a lot of energy loss there. We know it doesn't make a lot of sense, but getting all of that big ductwork out of the attic it's just too big. It's just too many compromises within the architecture of the home. And then that idea popped into someone's head. And I think the very first house we did was actually a net zero home in Pittsburgh.
Oh, wow.
And we used actually rigid duct. I think we actually used PVC pipe for the plumbing duct, but for the air duct, because we hadn't found anything at that time. And it worked fantastically well, right? Because you're right, a passive house, a house with very low leakage, is going to perform fantastically well.
Yeah, you can pretty much just run it with an ERV for the most part. So and also, like, the better the insulation, the less amount of duct you have to have per room. You need a certain amount of CFM at a minimum, but if you don't have a lot of energy loss to that room, then you don't have to have as many penetrations. So it actually, the more energy efficient the house, the smaller of a system, less duct work, and less things that you have to worry about going through there. But your system still works, for the inefficient house and also the efficient house, from what I can tell.
Yeah, absolutely. Yeah, obviously, the less air leakage in a house, the better, just from general rules, regardless of HVAC systems, right? You just don't want a house that leaks a lot. It causes all sorts of problems. And but I think the industry's getting there. Obviously, it's a cost equation as well, right? How much effort you can make to seal up a house, and the things you have to take into account when you do seal up a house better. Obviously, there are other things you have to take care of, like fresh air supply and so forth, right? But I think we're all going in the right direction.
Well, I appreciate your time. Are there any exciting things that you guys are working on for the future that you want to share with us, or do we just have to wait till 2023?
Wait till next year. Yeah, so this year is all about getting this system up and running and installed, and on a regular, frequent basis. And we're using the verified data to confirm the installations. We're doing all of that. And we're looking at, on the return side, we're looking at that. Some other things that just speed up installation time, the way we have our boots designed, and just simple things like the drywall cutouts, stuff that just looks at areas where we could improve our own efficiency for the contractors involved. Maybe a couple of designs with some alternative grill designs and some different colors as well. I mean, that's something that's obviously going to come on and makes sense, right? That we have some different designs there. But that's going to be the focus for this year. And then there's lots of other thoughts and ideas of how to control all of this as we look forward, and zoning and all of those kind of things. There's some great opportunity there.
Well, we definitely look forward to using this product on the 1920s house, and work with you on the design aspect and seeing how it works with passive house. That's really exciting as well. I know it's going to be a challenge for us to get everything built, but I know your product is definitely going to help us out. So I definitely appreciate your time. Thanks for joining us today.
I appreciate it, Matt. Thank you. It's great.
All right. Have a good one.
Take care.